Hello students, in this video I will be going through some exercises with you where we will be simplifying and rationalizing expressions. So this idea of rationalizing an expression simply means to rewrite an expression. If ever you see that there are radicals in the denominator, we have to get rid of it. Not get rid of it entirely, but we have to rewrite that expression so that there's no radicals in the denominator at all. Why do we need to do this? This is just a formality. It's kind of like, actually, no, I take that back. It's not really a formality. It's more like a way for people to convey ideas in a more smooth and logical manner. Okay, so you know how in English class or in history class where you're asked to write essays, and there's a way in which you can write more eloquently, right? So a way to do that is to avoid using the same words in the same paragraph, avoid using double negatives, okay, things like that. If you happen to use double negatives, or if you happen to reuse the same word within the same paragraph, it's not like you're breaking any laws. It's just that you come across not sounding as nice. So the same thing can be said about rationalizing. If you have an answer in a denominator, or if you have a radical in a denominator in your final answer, it's coming across as something that's not looking as nice. However, with that said, in my opinion, not everything needs to be rationalized all the time. But because we are practicing how to rationalize, okay, you're just going to have to go with the flow here. Some of the answers that you end up with after the simplification will end up looking even messier. So sometimes rationalizing can be rather contradictory, okay, because the whole point of rationalizing is to make make your final solution look simpler, but it ends up actually making it look a little messier. But again, the point of this exercise is just to go through the process of rationalizing. So let's take a look at how we can do this. So as I've said, okay, we want to avoid having radicals in the denominator. And one way in which we can turn something from that is irrational into rational is by squaring it. Because if radical 37 at the moment, radical 37 at the moment is an irrational number. So to rationalize this, if we square it, we'll end up with 37n to the fourth. You may be wondering, like, how are we going to be able to just square the denominator without having to affect the original value of the expression? And you're right, we cannot just square the denominator and call it a day. So to correct this, okay, what we need to do, there are two things that we can do in math, right? We can add 0, and that will not cause any changes in the original expression. Or we can also multiply by 1, and that will not cause any changes in the original expression. That's exactly what we're going to do. We're going to multiply this expression here by 1, by a very clever one. We're going to multiply by 37n to the fourth, radical 37n to the fourth, over radical 37n to the fourth. Why are we doing this? Because if we do this, then the denominator will be squared, and the whole expression will then become, the denominator will be rational. The whole expression will be rationalized. This is 37n to the fourth. In the numerator here, if I were to distribute this, I'll end up with negative radical 37n to the fourth minus, and if I were to multiply that through, I'll end up with 7 times 37, that would be 259, n to the 8th. And of course, we have to continue simplifying because I notice that there are things that we can pull out of the radicals. So I can pull out a n squared and an n to the fourth. And the denominator is 37n to the fourth, and I notice that there is a common factor of n squared between the numerator and denominator, so all of this becomes negative radical 37 minus n squared radical 259 all over 37n squared. Okay, so for this, okay, the denominator is rational now, okay, so the expression hence is rationalized. Let's take a look at the next one. here we have something very similar, okay? However, the denominator, okay, the second term here happens to be irrational. This term is irrational. So how can we rationalize this? Well, what we can do is we can multiply by the conjugate, because if I have this part here is rational, but if I were to multiply by, say, the conjugate of a plus b is a minus b. If I multiply by a minus b, what will end up happening is I'll end up with a squared minus b squared. So even though b was irrational, when I square it, this will become rational. And a, if it was irrational, it would also become rational. So this is the trick, right? We're going to multiply both the numerator and denominator by the conjugate, which is 8 minus 8 radical 5n to the third. And we're going to do this both for the numerator and denominator, because we cannot just multiply the denominator by some factor. We have to multiply the numerator with that quantity as well. So if we do this, we'll end up with the denominator, and I'm going to draw a really long fraction bar if you notice, right? The denominator will end up being a squared, which is 8 squared, minus b squared, which is going to be 8 radical 5n to the third squared. Okay, I'm just going to leave it like that for now. The denominator, okay, will be this quantity foiled. So I'm going to do a little bit of the scratch work down here. So this will need to be foiled with that. And unlike the denominator where I applied structure, right, to foil that out, the numerator is less forgiving. So this is going to be negative 48n plus 48n radical 5n cubed minus 24 radical 6n to the fourth plus 24 radical 30n to the seventh. And can I reduce any of the terms in the with this? I absolutely can. So this is negative 48n plus that 48n radical 5n cubed becomes 48n squared radical 5n. The 6n to the fourth, right? I can pull out an n squared, so that's 24n squared radical 6. And the n to the 7th, I can pull out an n to the 6th, which will become n to the third radical 30n. So this entire thing is my numerator. This entire thing is my numerator. And lastly, I'm going to get rid of this because I just finished that scratch work. Then this whole thing, the denominator becomes 8. So 8 squared is 64 minus 64 times 5. So that's 320 n to the third. And what I need to do at this point is I got to check to see if there are any common factors between a numerator and denominator. If you look closely here, everything here is divisible by 8. So my final answer is negative 6n plus 6n squared radical 5n minus 3n squared radical 6 plus 3n cubed radical 30n, all divided by 8 minus 40 n to the third. And that's my final answer. Whoops. Let's take a look at the next one. Really no different. So here, again, what I'm going to do is I'm going to multiply both the numerator and denominator by the conjugate. So this is going to be negative 7x cubed plus radical 7x squared. Negative 7x cubed plus radical 7x squared. Again, I want to rationalize this, and the only way that I can do that is by multiplying. If I have a minus b, the conjugate of that will be a plus b, right? And therefore I'll end up with a squared minus b squared. Both of these will end up being rational as a result. Okay, so with that said, let's try and work with this. And again, I want to draw a humongous fraction bar, just because this is going to come out looking insane. So negative 7x to the third squared, that's 49x to the sixth. And then radical 7x squared becomes 7x squared. The numerator is what I will need to actually FOIL out, because there's no particular structure or no form with that. So I want to do my little scratch work over here. So in order for me to multiply that out, negative 7 and 10 makes negative 70. X cubed, radical 2x to the fourth. And then plus 10 radical 14 x to the 6, and then minus, or actually plus 70x to the third, and then minus 10 radical 7x squared. And looking at this, there are definitely things that I can reduce. Okay, so the first term there, I can pull out an x squared, so it's negative 70x to the fifth radical 2. Next, I can pull out an x to the third, so it's 10x to the third radical 14 plus 70x to the third and minus 10x radical 7. So that right there, ladies and gentlemen, is the numerator. Pull that. Okay, and checking to see whether or not we have any common factors between a numerator and denominator. The denominator has a common factor of 7, however, the numerator does not have a common factor of 7, so that is my final answer. And, you know, sometimes looking at this, okay, because the answer is so complicated looking, I'm just going to double check to see whether or not this answer is, in fact, the same as what the answer key is. So question 11, let's take a look. Question 11, negative 7x to the fourth, radical 2. See, I made a mistake. I wrote x to the fifth, but it should have been x to the fourth. Oh, there is a common factor. You see, that's what happens when you do not look and you do not double and triple check. Notice that there's a common factor of x squared in the denominator, and there's a common factor of x. I can actually rewrite this entire thing. I'm glad I checked. So this has, so this 5 becomes a 4. Whoops. the 3 becomes a 2, and this is gone. So this becomes a 2, this becomes a 2, and that's just 10 radical 7. And the denominator, this becomes a 5, and that becomes a 1. So let me double check the answer again. And that is the correct answer. I'm going to double check the other answer for question number 7. Let me see if that was the answer. 3n cubed radical 30n. Let me see here. Yes. So this is correct. 8 minus 40n cubed. Yep. Okay. So let's take a look at another example. Ooh, we have 2 radicals here. So I promise you it's all the same. It's no different. This is radical, so we're going to multiply by the conjugate, right? So it's 5n to the 4th minus radical 10n to the 4th. Radical 5n to the 4th minus radical 10n to the 4th. And if I go through, the denominator is something that's nice and structured for me to re-express. So this becomes 5n to the 4th minus 10n to the 4th, right? The numerator is what's tricky here, so I'm going to multiply that out. I'm going to FOIL these, bring that a little closer together. So I end up with 3 radical 5n to the 4th minus 3 radical 10n to the 4th plus 3 radical 15 n to the 7th minus 3 radical 30 n to the 7th. And are there any things I can reduce? Absolutely. This is 3n squared radical 5 minus 3n squared radical 10 plus 3n to the 3rd radical 15n minus 3n to the 3rd radical 30n. And this becomes my numerator. I want to get rid of this. And looking at this, the denominator, or this whole thing, can be simplified even further, because the denominator will become negative 5n to the 4th. And I learned my lesson from before, there's a common factor of n squared. So I'm going to redo this, or re-express this. This is 3 radical 5 minus 3 radical 10 plus 3n radical 15n minus 3n radical 30n all over negative 5n squared. And the last thing, okay, because the answer key, they like to bring the negative up top, okay? So that's what I'm going to do too. So the negative, I want to bring that up top, and if I do, I'll end up with this as my answer. Okay? And let's just double check the answer. This is question number 13. Negative 3 radical 5 plus 3 radical 10 minus 3n radical 15n. Yep, that's the answer. All right, Let's do one more. I know this is a long video, but this is the last one. I feel like you guys need as much exposure to these types of problems as possible. So I'm doing one more. So this is 3 radical 5x to the third. Multiplying by the conjugate, this becomes a plus 2x squared. And both the numerator and denominator gets multiplied by the same exact things. So if I do this, okay, the denominator becomes 9 times 5 x to the third minus 4x to the fourth. 9 times 5 is really 45, so I'll just write 45. Okay? And then the numerator, again, that's what's tricky, okay? And where we need to be a little more patient. So we're going to FOIL that stuff out. So what will I end up with as a result? I will end up with 12x to the third, radical 5x to the third, and then plus 8x to the fifth, and then minus 12 radical 50 x to the fifth, and minus 8x squared radical 10x squared. And then there are things that I can reduce. This becomes 12x to the fourth radical 5x plus 8x to the fifth minus the 50 becomes 25 times 2, so I end up with 60, and x to the fifth becomes an x squared. So I'm left with 2x on the inside, and then minus that becomes an 8x to the third radical 10. So that's my numerator, which I'm going to bring up top now. Whoops. Hold on. So one more time. This is my numerator, which I'm going to bring up top. Okay, so are there any things that I can factor out? Absolutely. Looks like I can factor out an x squared, okay, out of every term. So my final answer is going to be 12x squared radical 5x plus 8x to the third minus 60 radical 2x minus 8x radical 10 all over 45x minus 4x squared. I'm just going to double check this because this answer looks really massive. So what question was this? This was question 17. So it's 12x squared radical 5x plus 8x cubed minus 60 radical 2x 8x radical 10. Looks like I'm in good shape. 45x minus 4x squared. Yes, and that's it. Okay.